So I'm a NASA scientist, and I can't speak without showing slides. My topic is the search for extant life on Mars. So the first, I just learned, the first experiment to actually detect extant life on Mars was the one that was talked about previously. The second one was the Viking missions. So the Viking missions were landed on Mars in 1976. That was 46 years ago. This is Carl Sagan, the young Carl Sagan, standing in front of the Viking lander, one of the Viking landers. Not the real one, but a mock-up. Surprisingly, the way the experiment worked was it was designed to basically culture soil microorganisms by the same methods that you would use to culture soil microorganisms on Earth. The results of that was done by 3 different experiments. They were designed to look for metabolism, and all of them detected metabolism. However, the way the experiments were interpreted was that these could not be biological reactions because they didn't look exactly the same way that a similar experiment done on Earth would look. They were actually kind of explosive metabolism, and 2 of the 3 instruments, when heat sterilized prior to doing the experiment, still showed a positive reaction. The 3rd one did not, and the developer of that experiment, to his dying day, claimed to have found evidence of extant life on Mars. Nevertheless, for the last 46 years, there has been no other experiment, in spite of all the missions to Mars, that have done anything to try to detect extant life. So in 2020, there was a workshop of astrobiologists who met and thought this really is something we should do something about, and identified, I'm going to talk about 3 potential habitats for extant life on Mars: salts and brines, ground ice, and caves. There were really 4, but in view of how I'm going to run out of time, I won't get into all of them. So salts. This shows a map here on the top. It's actually a topographic map of Mars, and shows where there are, all the white dots there are halite deposits. So these are white salts. Salts are known on Earth to host endolithic cyanobacteria that obtain water from water vapor in the atmosphere. Also, salts can actually host viable microorganisms in fluid inclusions that can last for 100 million years, can still be alive after 100 million years. So this is a near-surface environment which could potentially be habitable, only in certain locations, however. But there's another thing going on, which is this other weird salt that occurs on Mars, which turns out to have been a very important thing that we never thought about or even had the vaguest idea could be there, which is perchlorate brines. So basically there is this salt. Most of the chloride on Mars is actually tied up in calcium perchlorate. And it is a extremely deliquescent salt. It pulls water vapor out of the atmosphere. It also lowers the temperature of water, the freezing point of water, down to -70 centigrade, which is kind of like the mean annual surface temperature of much of the surface of Mars. A recent paper in Nature has shown that perchlorate brines can actually be deliquescent over a very large part of the surface of Mars for a substantial fraction of the year, causing a liquid water environment. And liquid water is sort of the limitation on Mars for availability of water, is the availability of anything to support terrestrial-like life. The caveat, however, is that this deliquescence occurs when the atmosphere comes close to saturation, and that only occurs because there's very little atmosphere to begin with, and there's very little water vapor in that atmosphere. So it has to get extremely cold for the atmosphere to come to a relative humidity that's high enough for deliquescence to occur, which ends up to be about 80%.
That's like dew.
Like dew, right? But dew is actually when it's already saturated. Deliquescence occurs before absolute saturation, but it actually pulls water vapor or water into a liquid state.
It's like a marine layer right up there. Salt.
Yeah, so anyway, the point is that at minus 60 to 70 at night, a lot of the surface of Mars suddenly has a liquid layer on it, but it's very cold. So the other thing that's been really recognized in the last couple of years is that ground ice is very widespread across the surface of Mars, and that the ground ice also is a place where deliquescence occurs, because there's always saturated conditions immediately above ground ice. This is, again, places, the white squares there are places where meteors have impacted and shown the presence of white ice. The rest of the areas are the, or the colored areas, not the red dots here, I forget what those are, but the colored areas are where on Mars the ground ice depth is supposed to be, and here I am now running out of time already. So things that I'm personally working on are missions to actually search for extant life. Have been for decades working on a mission called Icebreaker, which would drill into Mars ground ice and do a search for biosignatures of extant life. The other thing, though, is caves. So it turns out there's thousands of caves, sort of, skylight entrances on Mars, and caves can be windows into the subsurface that are more habitable, that are warmer, potentially, and wetter, potentially. They've been completely inaccessible until just recently, which has actually been the invention of helicopters. And I'm currently working with the team that invented the helicopters on Mars, which also came out of NASA Ames, by the way, to try to come up with a mission design for searching for subsurface life in caves. Maybe not even searching for life, but just trying to determine, are those habitable environments? In conclusion, this quest that I'm on about searching for life really is in conflict in my own mind with human exploration of Mars, precisely because we do not know the answer to the question, is there life on Mars? And yet we're, hell-bent for putting life on Mars anyway. I'm passionate about both things, but I do see that there is potentially a conflict between them.
Wonderful. Good question. Thank you, Carol. And David, if you could get mic'd up, you're next on. Okay, you already have a question with Creon.
Yeah, Carol, towards the beginning of your excellent talk, you mentioned that in spite of all of the missions and landers and instruments which have gone to the surface of Mars and even roved around and explored, making multiple measurements on multiple occasions, unlike Viking, there hasn't been any experiments to detect extant life. Since this can be off the record, by the way, do you have any thing to say about why it has been, whatever it is, 50 years or 40?
Almost 50 years, yeah.
Since we looked for extant life on Mars, in spite of repeatedly sending one probe after another to the surface.
Yeah, there's a one-word answer. No, I think it's the interpretation of the Viking biology experiments was heavily interpreted. Not so much what the actual results were, but the results were heavily interpreted as having shown no evidence of life, which was then conflated to be there is no life on Mars. So, you kind of had evidence that looked a lot like life, but was interpreted as not being life, and then that subsequent interpretation was there's no life. Then there was this other thing that happened on Viking, which was that they were so certain there was going to be life on Mars. And again, it was the very first thing we ever landed on another planet, right? Other than the moon. So we were, kind of way ahead of ourselves in terms of the Viking biology experiments. We didn't know anything about habitability of Mars. We didn't know where was the habitable environments, where was the good place to land. So, basically, after that, the geologists took over the program. And from that point forward, all of the missions have been driving around looking at rocks, or looking at rocks from space, or, from orbit, and have been very heavily involved in, let's try to find a habitable environment, which, you can, from Viking imaging even, you can see all this evidence of flowing liquid water, but it was billions of years ago. So that's basically what we've been doing, is driving around looking at rocks. And without instrument capabilities that had any ability to identify even biosignatures.
Why do you imagine that sending humans to Mars is in conflict with discovering life on Mars when the planet where we have both discovered life, both extant and prehistoric, is Earth, and precisely because we are here? Okay? If we were there, we would have far greater capabilities to discover life than we have now.
In my view, the risk is the risk of an inadvertent bringing of something back to Earth that could really endanger life on Earth.
Well, we've had billions of tons of Martian material transported to Earth through natural processes. So if there's the Red Death on Mars, it's already here.
And I understand that argument, but I still think it's if you look at a risk, the standard way engineers do risk matrix, right? There's a risk and a consequence. Maybe the risk is low, but the consequence is high. So it is, in my view, it is very inappropriate to send humans to Mars without having done any experiment to determine if there's life on Mars since Viking.
We have a lot of time for more questions over lunch, but for now I would love to hear your challenge for what would you like others to work on?
How can we do the risk assessment for human exploration from indigenous microbiology on Mars prior to landing humans?
For human, how can we do risk assessment for human?
It's essentially the risk assessment. It's not so much for the people that go to Mars, it's the risk assessment for Earth. Because once you go to Mars with people, you are bringing Martian biology back with you if it exists. And so that, to me, in my mind, it is a risk assessment that needs to be done.
Awesome, wonderful. Thank you, Carol.